All right, this is going to be just a quick example of how to work out the calculations for a serial dilution exercise. So, the whole point for a serial dilution is to determine the quantity of bacteria in a broth culture. All right, so let's say that we have a broth culture full of bacteria. Okay, and when we look at a live culture of bacteria, we can tell that it's full of bacteria because it's very cloudy, it's very turbid. It's so turbid that you really can't see through it. So, we can probably guess that there are billions and billions of bacteria in there, but we need to, try to get an accurate count. So we're going to start off with this original broth culture. And this is the culture that we want to determine how many bacteria they're in. And let's just say for this example, let's say that there are, as far as the volume of broth that's in here, let's say that there are about 5 milliliters of broth in here. Now that number, we're going to use that at the very end to determine the total number of bacteria. So we don't need the number yet, but we will soon. So to do this, what we're going to have to do is dilute this culture into sterile broths several times, and then take a diluted culture, a significantly diluted culture, plate that out onto an agar plate and allow them to grow to form colonies. Then what we do is we count the number of colonies on that plate, use that number, and also use the amount that the tube that those colonies came from, what we call the dilution factor, and back calculate to figure out how many bacteria are in this tube. So again, it's kind of a complicated process, but I'm going to go through it here. So to begin my dilution, let's say that I have a sterile broth here. Okay, and let's just say that this sterile broth has 4.9 milliliters of sterile broth in it. And as my first dilution, what I'm going to do is I'm going to pipette from the original tube to this tube. So this will be my first tube, and this is going to be my second tube. But from the first original culture into the second sterile broth to the second tube, I'm going to pipette 0.1 milliliters of this original concentrated culture into this sterile broth. Okay, so this is my first dilution. All right, now, before I move on, what I'd like to figure out is, by how much have I diluted by? In other words, what is my dilution factor in this tube? So to do that, what you do is you take the final volume in that tube and you divide that by the amount you put in. Right? So if the volume of sterile broth was 4.9 and I put in 0.1 mils, my final volume is 5 milliliters. Right? And if I divide that by 0.1 milliliters, I'm going to get 50. Right? So that means that the dilution factor in this tube is 50x. In other words, to restate it another way, the amount of bacteria in the second tube is 50 times more diluted than the original culture, the first tube. All right. Now, when we do a serial dilution, we usually have to dilute more because doing one dilution is usually not enough. Okay, so let's do this again. Let's bring in another sterile broth. And let's say that this time the amount of sterile broth in here is 9.9 milliliters. All right. And now what I'm going to do is I'm going to take a small amount from the second tube and dilute it into this third tube here. Okay, so we're going to go from here to here. We're getting successively more diluted. All right, so again, let's say that I'm going to take out 0.1 mils from the second tube into the third tube. All right, so what I want to do before I do anything else is to determine the amount that I diluted by between this second tube and the third tube. Okay, I need to know that number before I can figure out the dilution factor in this third tube. So we're going to do the same type of calculation that we did between tube 1 and tube 2. You take the final volume in tube 3 and you divide that by the amount we put into tube 3. So the final volume here is going to be 10 milliliters, and the amount we put in is 0.1 milliliters. And so when we divide that, we get 100. So just between tube 2 and tube 3, we've diluted by another 100 times. All right, but now, so what we need to figure out now is, what is the dilution factor in tube 3? Okay, by how much is tube 3 more diluted than the first tube? All right, well, to do that, you take the amount you diluted between tube 1 and tube 2, and you multiply by the amount you diluted between tube 2 and tube 3. So 50 times 100. Okay? So if you work that out, 50 times 100 is going to be 5,000. Okay, so that means that the third tube is 5,000 times more diluted than the first tube. All right, let's keep going. All right, so because again, usually we dilute like 4 or 5 times before we start plating out. So let me bring in another sterile broth. Okay, and I'm going to change the numbers around here. Let's say that the amount of sterile broth in this tube is 4.8 milliliters. And now, from tube 3 into tube 4, I'm going to pipette 0.2 milliliters. All right. So now again, we're going to figure out the amount we diluted by just in this step between tube 3 and tube 4. Just in that one step right there. Okay. So the final volume in tube 4 is 5, and we divide that by 0.2 milliliters. Okay. And so 5 divided by 0.2 is 25. Right? So that means between tube 3 and tube 4, we've diluted another 25 times. Okay. Well, now we need to figure out, well, by how much is tube 4 diluted? Is our culture diluted? In other words, what is the dilution factor in tube 4? Well, we're going to multiply all these dilutions. So we multiply 50 times 100 times 25. Right? And what I have now is I have a total dilution factor of 125,000 in tube 4. Okay? Now you can see that even though I'm changing the volumes in each one of these broths and changing the amount that I'm adding from one tube to the next, it really doesn't matter. The way that I work out the math is still the same. Okay, let's do this again. Let's dilute one more time before we plate out. Okay, so now what I'm going to do is I'll bring in another sterile broth. All right, and let's say that I don't know, this sterile broth has a volume of 9.8 milliliters. All right, and so this is my fifth tube. Okay, and now from tube 4 into tube 5, I'm going to pipe out 0.2 mils again. So again, we need to figure out by how much we've diluted just between tube 4 and tube 5. So my final volume is 10 milliliters, and I put in 0.2, right? So 10 divided by 0.2 is going to be 50. All right. So now to figure out the total dilution factor in tube 5, you take 50 times 100 times 25 times 50. All right. And what I have is 6,250,000 times. Okay. So that means, all right, this is what this means, that tube 5 is 6,250,000 times more diluted than the first tube. Okay, it's got that much fewer bacteria in it than the first tube. Okay, now, so now we're going to plate out onto different agar plates. All right, so let's say that, and this is, so let's say that from tube 4, we take out 0.1 mils out of tube 4, plate it out onto a plate. And let's say that after we spread the bacteria across that plate and let them grow in the incubator, and let's say that when we come back and we count our colonies, let's say that we count about 125 colonies. Okay. Now, we're also going to plate out 0.1 mils from tube 5, plate that out onto a plate, and let them grow and form colonies. And let's say that when we do that, we only get 6 colonies. Okay, so now we have a decision to make. We have to figure out, well, which plate are we going to use to determine to do our calculation here. All right, we have to figure this out. Well, the general rule of thumb is that to get an accurate count, you have to have anywhere from between 30 to 300 colonies. Okay? If you have fewer than 30, we say that it's too few to count. Okay? And if you have greater than 300, you have too many to count. All right? So I have one plate that has 125 colonies, and I have another plate that has 6 colonies. So I can't use the plate from tube 5 because there's just not enough colonies. I'm not going to get an accurate number. But I will use this plate because 125 colonies is right there between, 30 and 300. So that's perfect. Okay, so let's kind of work out our math. So the 125 colonies on that plate came from tube 4, came from a 0.1 milliliter aliquot from tube 4, which was 125,000 times more diluted than our original culture. I've got all the numbers that I need right now to work out my calculation. So let's do that. All right. So the first thing is, remember that the definition, what the definition of a colony is. Okay. So a colony is a group of bacteria growing on an agar plate that comes from one single cell. So in other words, when I transferred over 0.1 mils from tube 4 onto that plate, I wasn't really carrying over 125 colonies. I was actually carrying over 125 individual cells, and each one of those cells became their own colonies. So what I know is that there are 125 cells per 0.1 mils in tube 4. Okay, which is fine. I mean, that's a number, but I don't particularly like that number. I'd really like to figure out, well, how many cells per 1 milliliter there are in tube 4. So the easiest way to do that is to take this and divide it by that. And when you do that, you're going to get 1,250 cells per milliliter in tube 4. Okay. All right. So we know now that in tube 4 there are 1,250 cells per milliliter in that tube. Now we also know that tube 4 is 125,000 times more diluted than the first tube. So now if I take 1,250 cells per milliliter, and if I multiply that by 125,000, when I do that, that's going to give me the number of cells per milliliter in the first tube. Okay, why? Well, because tube 4 is that much more times diluted. It's got that much more fewer. So if I take the number of cells per mil in that tube and I multiply it by the dilution factor, that's going to calculate me back to that first tube. So when I do that, I get a really big number, and you can kind of run your calculations with me, but I get that there are 156,250,000 cells per 1 milliliter in tube 1, okay, in the very first tube, in that original stock culture of bacteria. So I'm almost done, all right? So I know now how many cells per milliliter there are in this tube, all right? And remember that I said that the total volume in that tube doesn't really come into play until the very last step? Well, here it is. So the last thing I need to know is, well, how many total cells there are. All right, well, if I take 156,250,000 cells per 1 milliliter, and I multiply that by 5 milliliters, that's going to give me the total. Okay, so my milliliter units are going to cancel out, and I'm just going to be left with the number of cells. So the number of cells that I have in this calculation here is 781,250,000 cells total. Okay, so that is basically how you work out the math. So even though in different examples that you might see the numbers in the tubes might change, like the volumes in the tubes might change, the amount that you carry over from the tube to the plate might change, and the amount that you're carrying over from one tube to the next might change. It doesn't matter. Don't get thrown off by that. The way that you work, the logic behind how you work out the math is exactly the same. All right. So I hope you found this helpful, and there you go.